Here we are in Blender, and Blender is a very powerful rendering tool, and we can now load some electron microscopy data with Microscopy Nodes into Blender. So for that, we first want to delete everything that is preloaded in the scene, and we do that by first tapping A and then tapping X. And then we here find in our scene properties our Microscopy Nodes panel. If you don't find this, you should follow the Microscopy Nodes install video, which will show up over here. Then we load our EM data, so I'm going to use a FIB-SEM dataset that I've included a link to the OME-Zarr dataset in the video description so that you can follow along, but you can also use your own TIFF. So I've put in my Zarr address, and we can see that it's recognized the dataset, and I'm going to pull this out a little bit, and then we can see exactly what we have here. We can here select the scale of the data. Because it is an OME-Zarr, we have multiple scales of the data saved together, so I'm going to go to this intermediate one, because these very large ones have the warning sign, because they're slightly too large for some of the parts of Blender. So if you're in the ray traced mode, they will work, but in some of the other modes currently, they will not work, so they can be used, but it's a little bit harder. So we're going to this S2 size. And then it reads out the pixel sizes for this scale, which is 40 nanometers, and the axis order, which is all correct. And then here we have our single channel of data. I also have a version of this data set with manual segmentations that my collaborator who made this data set made in Amira, but that will be in a specific video for label masks and surfaces. For now, we're just looking at only the data. And we can load that as a volume or as a surface. And then we have here a light bulb, which will say whether it's going to emit light. It's going to be white on a black background when we load it, or light on a black background, or dark. So we want this usually for EM data to be dark, so we turn off the light bulb. And then here we can pick a color of the data set. And so normally I would keep this on white. And then here there is a selection window for nonlinear color maps. And then we've set all of our things, and we can press load. And this will load the data from online and save it into this temporary folder. And that may take some time. It was quite fast for me right now because I already loaded this data earlier. And then we have our data, which is currently just a box. And so it's not very interesting. And that's because we're in the wrong render mode. So here there's multiple render modes. There is a rasterized render mode, which looks like this. It is slightly faster once it gets going, but it doesn't give all the information, and it isn't as pretty especially for the density rendering. So we usually go to this one where we see the ray traced version. And then here we have our data set. And here we have a summary of all the things in the scene, so we can see that we have the axes, and we have a slicing cube, which we can move either with these widgets, and like rotate it, or with hotkeys. So I usually use G, R, and S for this, but that is, so I'm also not that used to using the widgets. And then we can actually find that we here have our two nuclei, because this is a dinoflagellate right after it has divided. So if we go back to our scene properties, we go back to how we loaded it, we can also still change this color map to, for example, Viridis, where we have a little bit more color information. So this puts yellow at the highest EM densities and purple at the darkest. But we can also edit that in the materials. So that would be in here in materials. You can click volume, And then we do need to make sure that we have the volume selected, where we can first see here our lookup table for the colors, and here we have our pixel intensities. And that is more easily seen in the shading tab, which is here. And we can need to go back to a ray traced version. And that is here. So here we have also our histogram, and we can see our pixel intensities. But what's very relevant here is that we get a second box for our transparency, which is so clipping the minimum and clipping the maximum. So this makes sure that everything, if it's checked, everything that's right of the max for the clip max is cut out, is transparent. And if the left one, everything that is more left of the minimum is clipped out. So here we can kind of select which data to actually render in our scene. And it already looks quite fun and quite nice, but it doesn't look as pretty as Blender can look, and that is partially because the presets that Microscopy Nodes comes with are made for very fast rendering, because a lot of people don't have very strong machines. And here I am on a relatively recent MacBook Pro, so we can kind of crank up some of the settings. And there the most important one is in render settings here, in the volumes. So we can here then go to max steps and crank this a bit up, and that will take it longer per frame to sample, but it will make it also a lot prettier. Additionally, what's useful is that here you have in our volume transparency, so for our volume, we have a transparency slider, so we can make it just a little bit more dense, so it really looks like a big cube. And then we can select, for example, different structures by just clipping out both the min and the max, and we only include that range that is within our region of interest, our densities of interest, essentially. And so then, for example, here we can see quite a cool phenotype, that there are these tunnels through the nucleus that this dinoflagellate uses in closed mitosis, where it doesn't disassemble the nuclear envelope with mitosis. It makes a spindle through the nucleus. And so here it still has the tunnels through the nucleus that organized the spindle. But for example, we can also just select the chromosomes, because the chromosomes are really dense in this specific data set. So now we only have the dense things visualized. So we see that there are some granules on the outside that are very dense, and the chromosomes themselves. And we can see our two dividing planes. Then in here we can also still, again, replace our color map with, again, the single color, where we can change the single color by pressing this thing, or by right-clicking we enter this menu, and we can go through all of these menus to find exactly the one we like. And so what's fun is we can add now a camera to the scene, and we can animate all of this. We can animate the intensities, we can animate the thresholds, we can animate the slicing. So this gives a lot of ways for us to actually manipulate, to really show our data in context in 3D, which I think is a lot more informative than how we often look at it with just set slices. So thank you for watching. This was essentially how to get very quickly from our single channel EM dataset to a beautiful 3D rendered render. I will have also a video with the same dataset where I also include a lot of label masks, and that will also come up soon. Thanks for watching.